Well, welcome to our lesson on the law of cosines. In this lesson, we're going to be using the law of cosines to solve a variety of problems. And we're also going to use that to determine if a triangle is solvable using both what we've already learned about the law of sines and the new law of cosines. So a question for you, are there situations where the law of sines can't be used to solve a triangle? So in other words, another way of phrasing that is, what's the minimum amount of information that we need to use the law of sines? So far, if we had two angles and a side, we could do that, right? As long as we had two angles in any side, we could use the law of sines. So if we don't have that information, if we only have two angles, then we don't have enough information. Or if we had two sides and then one of the angles that was opposite one of the sides, we could use the law of sines. So if we have that information, we can use the law of sines, but otherwise we can't. So how do we solve a triangle if we know two sides and the angle that's included between them? So in other words, what if we knew side A and side B, but then angle C? If we didn't know angle A or angle B, what if we only knew side A, side B, and angle C? Well, in comes the law of cosines to help us. So our definition for the law of cosines is if we have any triangle, ABC, and we have the sides have the same letter, but they're lowercase from their angles, and these three equations hold true. We can say that side A squared equals side B squared plus side C squared minus 2BC times the cosine of angle A. So the thing you should notice about this is if we're trying to find angle A, we can find that as long as we know side B and C. Okay. If we want to find angle B and we know sides A and C, we can do that. Or if we want to find side B and we know angle B and then sides A and C. And then the third formula is c squared is a squared plus b squared minus 2ab cosine c. So just notice the relationship here. We can find this side if we know this angle and the two sides that make up that angle. If we want to find side B, we have to know angle B and the two sides that make up angle B. If we want to find side A, we need to know angle A and the two sides that make up angle A. Okay, so we'll use that not only to find a side, but it can also help us to find one of these angles, as you will see shortly. So here's our first example. We want to solve triangle ABC. Well, you can see we know angle C and the two sides that make it up. So we're going to use our law of cosines formula that I just showed you. So we're going to use law of cosines. Oh, and that didn't show up there, so I'm just going to delete that. There we go. Use law of cosines. So our law of cosines says this side squared is equal to these two, the sum of these two squared, minus twice the product times the cosine of the angle between them. So now let's plug in the stuff we know. So side A right here is 18, side B is 24. So we're going to do 18 squared plus 24 squared minus 2 times 18 times 24, cosine of angle C, which is 57. Plug that all into your calculator, and C squared is this number. Taking this square root, you get about 20.7. Okay, so we have found side C. The last two things we need to find are A and B. Well, the law of sines is pretty easy to use to find angles as long as we know the sides opposite. And since we know all three sides now, we can use the law of sines. So we're going to find angle A using the sine of A over A equals sine of C over C, because now we know both angle C and side A. And so substitute in what you know. And then cross multiplying like we've done in the past, and you get the sine of A as that decimal number, and then the inverse sign gives us angle A is 47. Well, now we know two of our three angles, so we can just subtract from 180, giving us angle B of 76. And notice these are all approximates, just because we're approximating here, so everything from there on has to be approximated. Here's another example of solving a triangle. This one we know three sides. We don't know any of the angles. So we're going to use the law of cosines to find the biggest angle first. Okay, so usually find the biggest angle first. So here we go, a squared equals b squared plus c squared minus 2bc cosine a. And substitute in what we know for the a, b, and c sides. The only thing we don't know is cosine a. So now this gets a little bit weird. So we need to subtract the 9 squared and the 7 squared from the 15 squared. And so I'll go ahead and do that. And then we're going to divide both sides by negative 2 times 9 times 7 to get the cosine a alone. Okay, so we're going to get cosine a is equal to this. Then punch all that stuff in on your calculator to get a decimal number over here. And you get the cosine of a is negative 0.7540. And we get 139 degrees. And that should make sense to you. This is an obtuse angle, so it's in quadrant 2, right? And the cosine is negative in quadrant 2. So there we have a positive angle, but its cosine is negative. So that all makes sense. Now we have a single angle. We can use the law of sines to get the other two angles, or at least another angle. And so I went ahead and used the sine of a over a is sine of b over b. Plug in what you know, cross multiply, and we end up with b being 23 degrees. Once we know two angles, we have angle b is 23 and angle a is 139. Add those together and subtract from 180 to get our third angle. So you have blanks in these ovals here. So we're going to use the law of sines, and this is a good thing to add to your note card. If we have two angles in any side, we're going to use the law of sines. If we have two sides and an angle that's opposite one of the sides, we're going to use the law of sines. If we have just three sides and no angles, we have to use the law of cosines. If we have two sides and then the angle that's between the two sides, that's also a law of cosines. So, see you in class and we'll get some practice on using these.